This is the University of St. LaSalle College of Arts and Sciences Mathematics Department. So this is the video solution of our problem number 3, okay, with difficulty of 1 star. Okay, so here's our problem number 3. If a is equal to the square root of bc and a is greater than 0, b is greater than 0, and c is greater than 0, then log b is equal to 2 log a plus x. So here we will answer what is the value of our x here. So I would like to mention those people who got it right, particularly the one who really got it in detail. So Albage Fernandez, who provided his answer with solutions actually. Thank you so much. His solution is quite different from what I will present here, but nevertheless similar and will yield the same answer. Okay, with Albert's permission, I will show you his solution later in this video here. Okay, so here we are asked to determine what is x in this equation, okay, which has logarithms. Okay, so you can see here logarithm and logarithm. So well, logarithms, as you can remember, are the inverses, or rather the inverse functions of exponentiation. That is, to get the logarithm of a number, say x, of a base b, you will need to know the exponent in which will produce that x under that base b. Okay, so here we'll use the first given here, which is a is equal to square root of bc. Okay, and we have here some a greater than 0, b greater than 0, and c equal to greater than 0. This here just guarantees us that the variables are all positive, okay, which is abc abc are positive integers, okay, or positive real numbers. So that will not end up with the square root of 1 or square root of -1 in this part here. That is, will not reach the complex numbers. Okay, see that in this equation here where x is located, we have this equation wherein log b is isolated on the left hand side of our equation. So we will use this information there and we'll try to get the value of b here. Okay, so that will be our first step. Okay, so we'll have the square root of bc equals a. Okay, so we need to get the value of b. After that, we're going to plug it in here in this log b here. Okay, so squaring the both sides will yield us this one. We did that so that we could get rid of the squared symbol. After that, we need to get the value of b. So we need to isolate b here. That is by dividing c on both sides of the equation, and we will have this number. Okay, so we have b is equal to, you can read it as this, b is equal to a squared over c. So we will use that information, okay, and we will plug in that in our log b. Just put lines so that we can separate things, highlighting this by a square box. So log b is equal to what number? So we can use it like this. Okay, so log b is equal to, well, we know log b is equal to log b, but in the right hand side we will use the value of b as in this, okay, a squared over c. So log b is equal to log a squared over c. So we will use one property of logarithms wherein this dividing part here could be changed, okay, wherein if we have a log a squared over c, we could change that by converting dividing or the division into subtraction here. Okay, so log a squared, that's the numerator, minus log c, that is the denominator. Okay, after that, that's one property of logarithms. Next is, we will try to make it exactly like this. Okay, so 2 log a. So where did the 2 come from? And as you can see, the square in the a vanished. So we will use another property in logarithms wherein we will transfer, okay, the exponent in the logarithm part, okay, to the coefficient part of the log. Okay, that's another property of logarithms. So if our number is raised to an exponent, we can transfer that exponent to the coefficient of the logarithm, which will look like this. Okay, so log b equals 2 log a minus log c. So as you can see, this pretty much looks like our then part in our statement here. So to make things clear, let me clear that out, let's write it again. So this is the last line that we got, and I will write our then statement above here, and we will try to compare. So they are really like the same, Notice our x here, okay, they match. Our x here is the value we're looking at here, is your value here. So clearly, we have our x, therefore, our x is equal to negative log c. Okay, and this will be the answer for our problem number 3. Okay, so x, the one that we're looking for, is equal to negative log c. Now, as promised, I will let you see the solution of Albridge-Fernandez. As you can see here, it's pretty much in detail. So let me read. A equals square root of BC and ABC is greater than 0 implies log B equals 2 log A plus x. So what is x? That's my original statement in a more mathematical terms. We observe that A is equal to square root of BC if and only if log A is equal to log square root of BC. So in this part, Albridge put it directly on the log part. So we could just put log here and log here so that it will look like this. But the power property of logarithm on the right hand side of the equation is equivalent to 1/2 log BC. So imagine square root of BC is BC raised to 1/2. So using that property, transferring the exponent to the coefficient, the same thing that we used, so 1/2 log BC. Thus, multiplying 2 by both sides yields this one. Okay, 2 log A equals log BC, so that we could get rid of the 1/2. By the product rule of logarithms, the right-hand side is equivalent to log B plus log C. The same thing that we did, only that in our case, that was division, changed into subtraction. Here, in Albridge, it's multiplication, changed to addition. Okay, so we need to isolate log B in this part. We will then add the inverse of log C to both sides. Hence, we have log B equals 2 log A plus negative log C. So which is equal to 2 log A plus x. So what we're looking for is here. So therefore, where x is equal to negative log C. So that was Albridge's answer. So we have a slight variation of our processes, and yet we both yield the same result. Okay, so well, this is one of the things that is beautiful in mathematics. That it is not rigid. Okay, you can do it in several ways, provided, of course, that your solutions obeys the algebra, okay, obeys the principles, obeys the laws, and well, it does the maths correctly. You should do the maths correctly, even though the processes are different. Okay, so that's it. We'll be posting more math problems, so try checking out our Facebook page for our math problems. So this is our Facebook page. I'll provide a link on the descriptions below. And please try not to forget to subscribe to our channel. That's it. That finishes our problem number 3. Thank you so much.